Okay, perfect. Thank you everybody for being here in the inaugural seminar of the series of seminars in economic psychology. This is the official seminar series of the International Association for Research in Economic Psychology, which is the flag association for interdisciplinarity between economics and psychology. Today we are going to have Ernst Fehr, nobody better than Ernst, to start the seminar series. He's a pioneer in experimental economics and behavioral economics, and really an interdisciplinary scientist. In the next months, we will have Cass Sunstein, IAREP, Marta Serra-Garcia, and Cathy Milkman. And just two reminders for everybody, the IAREP also sponsors the publication of the Journal of Economic Psychology, which currently is the journal with the highest impact factor in all of behavioral economics and judgment and decision making. And the IAREP also sponsors one yearly conference, which is the IAREP conference. And as a reminder, the next conference, the 2023 conference, is in Nice, in France, on 7th to 10th of June. And the submission deadline is on February 10th, so you still have time. Without further ado, we are all here to listen to Ernst. So Ernst, if you want, you can start sharing your slides.
I will do so.
And thank you very much for being our first speaker. We really appreciate it.
Can you see my presentation?
Yes, we can.
Okay. So thank you very much for giving me the opportunity to speak in this distinguished speaker series. I will talk today on a topic that is close to my research program on social preferences. Title of the paper, which is soon to be finished, is The Fundamental Properties, Stability and Predictive Power of Distributional Preferences. It's a joint paper with Thomas Epper and Julien Sen, and the R between our names means that we randomize the author order. So there is for those of you who don't know this, there is a public randomization mechanism available at the American Economic Association webpage that allows us to randomize the author order so that not always the people with an A in their family name are the first authors, and the people with a Z are the last authors. Okay, so let me start by motivating my presentation. Social preferences have been shown to play a potentially very important role in many different spheres of life. They have an impact on labor markets and good markets, on contract and mechanism design, how organizations and institutions function. They play a role in political economy and for charitable donations, and so on. But to really pin down, to go beyond theory, and to really pin down the role of social preferences empirically, we need to know the empirical distribution of these preferences in the broader population. And ideally, we would like a parsimonious description of this distribution. Now, I want to ask 4 research questions in this context. The first question is it possible to identify the distributional preferences of broad population samples in a non-parametric way in terms of a small, that means parsimonious, number of preference types without ex ante assuming pre-existing types? And in particular, can we identify all the empirically relevant global types while staying parsimonious? So will there be a proliferation of types, or will there be a small number of types that comes out from such an approach? And can this be done in an agnostic way, in the sense that we don't make ex ante assumptions on the existence of types, but we let the data speak? The next question then is, if the first part is possible, then the next question is, what are the fundamental properties of the different types? And by this, I mean, what are the qualitative behavioral characteristics of the preference types? And can we assign each individual to one of these types? The third question is then, how stable are these types? In other words, how stable are the fundamental behavioral characteristics of the preference types across different subject pools and over time? And how stable is individuals' assignment to preference types, or do individuals switch between preference types over time? And finally, we asked the question, is this behavioral characterization predictive of behavior within and between samples? In other words, is parsimony, so that we have a small number of types, associated with a large loss of precision in out-of-sample predictions? Or is a parsimonious description in terms of a small number of types nearly as good as predictions based on individual preference estimates? And finally, are type-based predictions better or worse than predictions based on machine learning models? So these are our 4 broad research questions. And now let me tell you why I think this is interesting. This is an interesting program. Well, our agnostic non-parametric approach does not face the danger of overlooking important types. So if you assume ex ante that certain types exist or don't exist, you always run the risk that you get it wrong. Instead, when you have a non-parametric approach that lets the data speak, you don't face that problem. Further on, it's still possible to use utility theory and structural estimation of utility functions after you have recovered the types. But that turns around, so to speak, the relevant questions. When you have a parametric approach, you assume ex ante some types, and you assume the utility functions that are corresponding to these types. But this is an assumption, and so you restrict your empirical research programs ex ante. Instead, we turn it upside down. We ask which types exist, and once we have discovered the types, this discovery then suggests basically certain preference functionals. So the preference functionals are then implied by our empirical results and not ex ante assumed. Furthermore, parsimony improves clearly tractability. So if I'm parsimonious instead of very complex, that simplifies things and it mitigates the risk of overfitting. Just to give you an example here, suppose you have 1,000 individuals and you estimate utility functions with 2 parameters per okay. That means with 1,000 individuals, if you estimate the utility functions at the individual level, you basically estimate 2,000 parameters. Whereas if I have, for example, just 3 types, I have 3 times 2 parameters. So I describe the whole data set instead of with 2,000 parameters, just with 6 parameters. So there could be a dramatic increase in parsimony in the sense that we estimate much fewer parameters and therefore mitigate the risk of overfitting the data. Fourth, stability of preferences is a hallmark of economics. Therefore, it's important, or that's an assumption basically, but it could be wrong. The assumption could be wrong. And so it's important to know whether types and individual assignment to types is stable. And finally, good models make good predictions. That means we need to know how much, if anything, do we lose in terms of predictive power when relying on a parsimonious type-based characterization. So how do we measure social preferences in our experiments? Well, subjects make many incentivized money allocation choices between themselves and anonymous partners. By the way, Carlos, I have a question. How do we deal with questions from the audience?
They can raise their hands and then we can allow them to speak.
So you can always, so I have no problem if you raise your hand and interrupt me and have intermediate questions. So you don't just have to listen all the time to me. So it becomes more discursive then. Okay, so how do we measure distributional preferences? Well, we have this money allocation task where subjects allocate monetary amounts between themselves and anonymous partners. And we do this with so-called negatively sloped budget lines. You see here a negatively sloped budget line in the space of own payoff, that is X own, and other payoff, X other. And on this negatively sloped budget line, we can measure whether individuals are willing to reduce their own earnings to increase the earnings of the other individual. So here we can measure the willingness to pay to increase other individuals' payoff for the sake of an altruistic motive, or for the sake of an equality motive, or for the sake of an efficiency motive. There could be various motives why people might be willing to reduce their own earnings to increase the other individuals' earnings. But we will also have positively sloped budget lines that identify a willingness to pay for reducing others' income. So if the individual on this positively sloped budget line moves down this budget line, it displays a willingness to decrease its own earnings, to go left, in order to decrease the other individual's earnings, okay? And this is the type of budget lines that we have in our experiment. And the overall number of budget lines we use for identifying preferences are the budget lines that you see here graphically displayed. So what you see here, these are budget lines with many different slopes for transferring money to the partner or for reducing money of the other partner. And because we have many different slopes, which is basically another way of saying many different cost levels of engaging in transferring money or reducing the partner's money, we get a very fine-grained measure of individuals' distributional preferences. In particular, we can truly identify the selfish types much better because we have these different cost levels. For example, we can identify with this approach preferences for altruism or for increasing the total payoff of both players. We can measure preferences for envy or spite, for advantages and disadvantages, inequality, aversion, etc. Now, here we of course don't show the individual's budget lines, because this is a presentation format that's very unintuitive for the individuals. Instead, we show them what you see on the left-hand side of the screen here. We show them bars that tell them how much they receive if they choose that bar and how much the other person receives. And it's displayed in graphical terms. There are always seven interpersonal allocations available per choice, and the format makes the distributional consequences of each allocation quite transparent. Okay, so this is the presentation format. Now, what are the data that we use? Well, we have two big data collection waves that give us 3 samples and 4 data sets. We have subjects who participated only in the 2017 study. We have subjects who participated only in the 2020 study. They are 3 years apart. We have a panel sample where the same subjects participated in 2017 and 2020. In total, that gives us 4 data sets, only 2017, only 2020, panel 2017 and panel 2020, with a total of 1,730 individuals. Notice, for each individual data set, the sample is broadly representative of the Swiss population in terms of age, gender, and region. Okay, so now how do we measure or identify behavioral heterogeneity in a non-parametric way? Well, as I already pointed out, we don't want to make assumptions on the behavioral characteristics of the different types and on the number of types in the feasible preference space. For example, it could be possible that we identify 2 very different altruistic types, for example, strong and a weak altruistic types. It could be possible that we identify a strong and a weak envious type, or like we did in Bruhin et al., where we found 1 envious or spiteful type and 1 weak altruistic type and 1 strong altruistic type, and so on. So it's everything, a lot is possible here, okay? We also do not want to make any assumptions on utility noise or error structure, which would be required if we apply a structural econometric approach to this problem. And why do we shy away from going that route? Well, we know from a lot of evidence that that choices have a random component. That means choices are driven by preferences, but also by noise. And the random utility approach, for example, requires untestable assumptions on noise. Otherwise, utility function cannot be identified. If you like, we can go into this discussion. For some, that may be surprising, but I have a recent paper with Carlos and Nick Netzer where we show this to be true. You need to impose untestable assumptions on the noise when choices are random. Otherwise, you can't identify individuals' preferences. And what's even more important here is that these assumptions on noise drive your inferences about preferences. You know, it's kind of intuitive why that is the case. If it's preferences plus noise that determines choice, then you have to put structure on the noise to infer the preferences, because otherwise you always can only infer a composite of preferences and noise, unless you impose the structure. Now there are ways to overcome this with an approach we developed with Carlos, but here we take the route that we rely on, we don't impose any assumptions on utility, noise, or error structure to recover the preference types. What do we do? Well, we apply a non-parametric clustering algorithm that's called Dirichlet process means, and that's a generalization of a k-means algorithm. In the k-means algorithm, you have to fix the number of types ex ante. You don't have to do that in this Dirichlet, in this DPM means, in this DPM approach. And in our application, the preference clusters are based on subjects' 12 distributional choices that I have you shown previously on these 12 different budget lines. And the similarity, the assignment to a cluster is decided based on the similarity or the closeness that an individual has to the average allocation that is chosen in a cluster. Now, what are the properties of this DP means algorithm? This is partly a repetition of what I already said. Well, it meets all the requirements that we want it to meet. We make no ex ante assumptions on which type exists, on the preference functionals, and on the utility noise or error terms. The model allows, in principle, for a full continuum of types. So in principle, it could be the case that there are 20 types emerging, or that the 5 types are emerging, or that there are 100 types emerging. But so the model allows for that. It also would allow to, for example, for a case where just one type emerges, okay? And what DPM also does, it formalizes a trade-off between parsimony and descriptive accuracy, because you have to make one assumption. You don't have to make all these assumptions that I have described here, but you have to make one assumption. You have to assume a cost for additional types, okay? So it requires you to assume a cost for additional types. But then when you have assumed this cost, the number of types and their behavioral characteristics, they emerge endogenously from the algorithm, and each subject is assigned with certainty to one of the preference types. Okay, so now next question is, do the descriptive data that we find from the experiment already provide hints about the number and the characteristics of the different types? So sometimes, I mean, we use the DPM clustering algorithm to rigorously, so to speak, derive the number of types. This is the kind, if you like, this is the rigorous approach behind what we do. But ideally, the data tell us already something at the descriptive level about the number of types, whether there are types. And because when you can eyeball the results, then the results are much stronger. And in order to potentially eyeball what we find, to see it with your naked eye, we represent the choices of an individual I in situation K by a number. It's called set IK. What is this number? And it's a number between 0 and 6. So here you see how we do this. You have here a negatively sloped budget line. When the individual on a negatively sloped budget line behaves totally selfish, so maximizes own income, then we say set equals 6. This is just a convention that you need to remember for when I describe the results later on. When the individual equalizes, when the individual chooses an allocation that is on the 45-degree line, so such that both players get the same payoff, we call it set equals 3. And when the individual minimizes own income, which in this case is identical to maximizing the other individual's income, because the individual gives up own income to maximize the other's individual income, then we call it set equals 0. So just recall, set equals 0 means minimize own income. Set equals 3 means equality. Set equals 6 is maximize own income. And the same holds true for positively sloped budget lines. Again, set equals 0 means minimizing own income. Here, the individual on this positively sloped budget line minimizes own income at the bottom of the budget line. Set equals 6 means maximizing own income, and set equals 3 means equality. Now, the difference between negatively and positively sloped budget lines is that minimizing and maximizing own income has different meanings. Because if I maximize my own income on a positively sloped budget line, I simultaneously maximize the other player's income. Okay? Whereas if I maximize own income on a negatively sloped budget line, I simultaneously minimize the other player's income. Okay? So it has a different meaning, maximization of own income and minimization of own income on differently sloped budget lines. But abstractly, we use always set equals 6, set equals 0, set equals 3. So now let me give you an idea of what potential preference clusters could emerge. And let me assume that, let's say, the data are clustered around this black circle. Now, what you have on this graph is we graph here we take here all the positively sloped budget lines. So this is the plus here. We take all positively sloped budget lines and look at individuals' median choices among the positively sloped budget lines. Okay. And on the vertical axis, we look at individuals' median choices on the negatively sloped budget lines. And if the individual always maximizes own income, then we assign set equals 6, and that means we are in this black cluster here. And that means a selfish cluster, because the individual always maximizes his or her own income. Now, what is this cluster here? Well, this is a spiteful cluster. Why is this a spiteful cluster of individuals? Well, on the negatively sloped budget lines, the individual has a set equals 6, the median choice of the individual is selfish. It's basically maximizing own income on the negatively sloped budget lines. But on the positively sloped budget line, the individual goes to very low sets. And low sets means minimizing own income. And minimizing own income on positively sloped budget lines means really also minimizing the other guy's income. So this is a really mean behavior. I incur cost to minimize the other guy's income. And this is why we call this spiteful. Now, we could potentially also have an inequality averse cluster or an egalitarian cluster when the individuals go to the middle always. Or we could have what could be called egalitarian altruism. Egalitarian altruism would be a situation where the individual on the negatively sloped budget lines goes into the middle. You know, the individual equalizes income on negatively sloped budget lines, and that means it goes for equality. But on positively sloped budget lines, the individual goes for maximizing own income, which on positively sloped budget lines is identical to maximizing the other guy's income. There was somebody who raised, so Bernhard Schmidt raised his hand. So could he say something, or how do we do this? I saw somebody raised his or her hand. I don't know how the participants who listen can speak or can be.
We saw a raised hand, but the hand is not raised anymore. So if you have a question, could you raise the hand again? Then I can unmute you.
Okay.
So far, there's no.
Maybe I answered the question already.
Yeah.
Hopefully. Okay. So, but there could also be other types. For example, there could be weak altruistic types, which means they maximize their own income on the positively sloped budget lines, but don't go into the middle on negatively sloped budget lines, but they go further in the direction of selfishness on the negatively sloped budget lines. Or they could be strong altruists who go basically, who maximize own income on positively sloped budget lines, but minimize their own income on negatively sloped budget lines, which is here, which means they give a lot of payoff away to the other guy if they minimize own income on negatively sloped budget lines. So there's a lot possible here. And I want to, I put a lot of effort into explaining what could happen. Okay, now let's say what actually happens. So we represent now, we have now the 4 different data sets, and each individual is represented by a dot in this space of median choices on positively sloped budget lines and median choices on negatively sloped budget lines. And what you see in the 2017 only sample is clustering around 3 types, basically: an inequality averse type, an altruistic type, egalitarian altruistic type, and a selfish type. And when we look at, there are some individuals who are distributed, but the majority of the individuals is really right straight on the point where they can be easily assigned to a type. Now, in the 2017 panel sample, we see the same 3 clusters. In the 2020 only sample, we see the same 3 big clusters. And in the 2020 panel sample, we see the same 3 big clusters. So this is was quite surprising to us, that in all 4 data sets, we see a clustering around very similar behavioral types, okay? And that already tells you quite a bit about the stability and so on. Now, the question then is, does the clustering algorithm identify the same types in all our samples? And the answer is basically yes. So what we find here is that across all 4 samples, which are in the columns here, you see an inequality averse type, typically comprising between 45 and 50% of individuals. We see an altruistic type, typically comprising between 30 and 40% of individuals, and a selfish type comprising between 10 and 24% of individuals. Now, what is quite interesting here is that the selfish type is in the minority. And the reason why the selfish type is in the minority is, I think, because we have this fine-grained, we have these very different cost levels, many different cost levels that allow us to disentangle selfishness from other regardingness. So basically, our parsimonious preference characterization, therefore, is rather stable across samples and over time. So this aggregate preference characterization in terms of types seems to be rather stable in the sense that the same types emerge, okay, in 4 different samples. So Thomas Eisfeld raised his hand.
Allow him to talk.
Thomas,
can you hear me?
Yeah, I can hear you.
Hi. So thanks a lot. But it seems to be that in altruistic preferences seem to be a downwards trend over time, right? Where for selfish preferences seem to be some sort of like upwards trend. Can you talk briefly a little bit about that?
Yeah, you see this here. Well, we have, to be honest, we didn't, well, we have the 2020, it's not totally, I mean, when you go from panel 2017 and panel 2020, so these are identical individuals in the panel. Then you see we have we go from 42 to 39 basically. is this a significant downwards trend? I'm not sure. Now, the other differences, when you go to 2020 only, this is really a different sample that we drew there. You know, it's still representative in terms of age and gender and geographical distribution, but it's still a different sample, so that could also be the sampling variation. So strictly speaking, you can only talk about trends here. And there is then, if you see, there is a bit of a trend here that also there's 3% less inequality averse and there is 6% more selfish guys. But why this is the case, we didn't investigate this more deeply, to be honest, at least so far.
I see. Thank you very much.
Okay, thanks for the question. Now,
just they add up to 100%. So did the number of people who could not be assigned change over the time? So are they roughly the same as well?
I come to that. So basically what's important is the DPM algorithm assigns each individual with certainty to one of the types. Now, this is an asset and a drawback at the same time, because some types, as you have seen, some of the individuals, they are not directly on the spot where they are perfectly equal to these types. And if they are just at the boundary, they may switch, the assignment may switch over time, for example. So that may be one reason. But I come to the stability question more explicitly. For example, before I come to the stability question, let me first ask another important question. So are there really 3 types? Okay, now, could there be fewer than 3 fundamentally distinct types? And we tested this. How can we look at this? Well, we can make the complexity cost that you have to choose in the DPM algorithm. You have to choose a cost for new types. And if the cost is very high, then you reduce the number of types to 2, but what then happens is that the selfish type disappears and is merged with the other 2 types. And that implies that the behavioral interpretation of the other types becomes unclear, and that the stability of the behavioral characterization of types across data sets vanishes. Okay, and it undermines the predictive power of type-based prediction. So there's very good arguments against the existence of just 2 types. And it also undermines the stability of individuals' assignment to types. So there are very strong arguments against the existence of 2 types. Now, the next question then is, could there be more than 3 fundamentally distinct types? So in order to check this, we lowered the complexity cost so that it becomes less costly when the algorithm generates more types. And by allowing for 4 types, we find that no new meaningful types appear. There's only one sample, the 2020 only sample, where the inequality averse types split into 2 subtypes. Okay. And in the other samples, the 4th type basically remains unpopulated, which unpopulated means that less than a half percentage point of individuals is populating this type. The same conclusion follows if you allow for 5 types. So the 5th type basically remains unpopulated. So we are pretty sure that there's only 3 meaningful types here, and that they describe the data set quite well in terms of the when we ask the question, what fundamentally distinct types exist? Okay, now this is Switzerland. I thought I'd show you also Danish data where we did the same in Denmark, where we have 3,600 individuals with a similar, basically a very similar experiment. And what we find is, again, these 3 types. So in Denmark, we find, again, 3 big clusters: inequality averse types, altruistic types, selfish. Now, the relative shares of the types differ. It's more like 1/3, 1/3, 1/3 compared to the Swiss data set. And when we apply the DPM algorithm, that algorithm again gives us these 3 types. Okay, so let me summarize the behavioral characteristics of the different types. And I do this now with a theoretical tool that's called indifference curves. So what are the indifference curves that are implied by the existence of these three types? Well, here you see the results. The selfish types, they have, when you have own payoff on the horizontal axis and others payoff on the vertical axis, then the selfish type has basically a vertical indifference curve. And more own payoff is always better, regardless of what the other guy gets. That's the green vertical budget indifference curve here. The altruistic type has always a negatively sloped budget line. Why? Because the altruistic type has a positive willingness to pay so this type is willing to reduce own income to increase the other guy's income when ahead, so when below the 45-degree line. But this type is also willing to decrease own income in order to increase others' income when behind. But typically this willingness is a little bit less when behind. So this is why this curve is, well, this slope is steeper than this slope. And then there is an inequality averse type, which has a willingness to pay, so a willingness to reduce own income to increase others' income when ahead, below the 45-degree line, but also a willingness to pay to reduce own income. So basically a willingness to reduce own income to decrease the other guy's payoff for the sake of reaching an egalitarian allocation. Now, what this means in terms of a model of a preference model, when you write down a Fehr-Schmidt utility function, which I will do later on, then and you have two parameters, an alpha and a beta in that utility function, then an inequality aversion means that alpha, which is a dislike of disadvantageous inequality, is positive and beta is positive. Whereas the altruistic type means that beta means the dislike of advantageous inequality. So this is below the 45-degree line. They have also a beta that is positive, but an alpha that is negative, the altruistic type. Now, let me say something about the difference, because I assume that many people are psychologists that also listen. And in psychology, there is a well-known concept called social value orientation. So what is the difference between our characterization of individuals' preferences and the social value orientation approach? Well, the social value orientation approach also gives people allocation choices where they choose between own and others' income. Different allocations that give different amount of money to self and others. But the way the overall results are aggregated and summarized is very different in that approach. Because the social value orientation approach, for example, rules out inequality averse types. The social value orientation approach allows for basically three types: a selfish type, a competitive type, which would be this red indifference curve, but it would go further down here. So it would be throughout negatively sloped, and an altruistic type with a throughout negatively sloped indifference curve. So there are basically the approach, how it is conceptualized, assumes three types: individualist, which is the same as selfishness, cooperative types, which is the same as altruistic types, basically, and competitive types, which is the same as spiteful types or envious types. But it doesn't allow for a type that is simultaneously altruistic and envious, which is the inequality averse type. This type is simultaneously altruistic in the domain of advantageous payoffs and envious in the domain of disadvantageous payoffs. And the social value orientation approach doesn't allow for that type. Now, I think this is an important difference that could be interesting for the people who work in this area. And then there is another finding which I find really amazing that we uncovered. We do at some point parametrically or non-parametrically, it doesn't matter. We do estimate the correlation at the individual level between the alphas and the betas. Now recall, what do the alphas and the betas mean? The alphas and the betas are basically, the alpha is basically an indicator of the slope of the indifference curve in the disadvantageous domain. And the beta is an indicator of the slope of the indifference curves in the advantageous domain. And if there is a positive correlation between alpha and beta, then that means for the inequality averse type, the flatter this line here is below the 45-degree line, this indifference curve below the 45-degree line, the flatter is also the indifference curve above the 45-degree line. In other words, the more generous an individual is, when an inequality averse individual is, in the advantageous domain, the more envious that individual is in the disadvantageous domain. And that's quite remarkable. The more generous they are here, the more envious they are above the 45-degree line. So that's one of the implications of the positive correlation between alpha and beta. Now, what does this positive correlation mean for an altruistic individual? Well, for an altruistic individual, a higher beta means more generosity. It means flatter indifference curves. So a higher willingness to reduce own income to increase the other guy's income, okay, when it's flatter. So higher beta means more generosity. And higher alpha means, notice that for an altruistic individual, this alpha is negative, okay? This alpha positive means it's positively sloped, this indifference curves. Alpha negative means it's a negatively sloped indifference curve. And if a negative number becomes bigger, then it goes from, let's say, from -2 to -1. That means in numerical value, it becomes bigger. Okay, higher beta means higher alpha, going from -2 to -1, which means this indifference curve gets steeper here. And that means the more generous they are in the advantageous domain, the more selfish they are in the disadvantageous domain. That's quite, it's also quite interesting. So for altruists, it means more generosity goes together with more selfishness at the individual level. For the inequality averse type, it means more generosity goes together with more envy. And I think this is a novel fact that, to my knowledge, has not been discovered yet. Okay, so next question then is, how stable are individuals' type assignments over time? For example, does an individual identified as inequality averse in 2017 remain inequality averse in 2020? Here you see the transition metrics in the panel sample. And what you see here is that roughly the bold numbers indicate the stable types, so to speak, the stable individuals. And we have in total, if you add up these numbers, 68% of individuals are assigned to the same behavioral type. Extreme type switching between selfish and individuals with other regarding preferences is relatively rare. It's 15%. There is some switching between inequality averse and altruistic types. And this raises two questions. Why does type switching occur? And how temporally stable is subject's individual behavior? Now, let me go to the first question. So why does type switching occur?
We have a question from the audience.
Okay. So ask the question.
Pedro Gonzalez.
Yes. Pedro?
I think he has disappeared now for some reason. Sorry.
Hello.
Hello.
Yes, it's a very quick question about the previous slide.
This one here?
Yes.
Okay.
Because you said I also found it quite interesting that you found a very positive, strong positive correlations between the alpha and the beta parameters. But do you find it also for all types?
Well, for the selfish types, they have anyway an alpha and a beta that's close to 0. So
I mean for the altruistic and the inequality of it.
Yes. we have, it's true for both types. It's true for the inequality averse types and for the altruistic types. But it means different things for the inequality averse types and for the altruistic types. For the altruistic types, this correlation means at the substantive level that the more generous you are in the domain of advantageous inequality, the more selfish you are in the domain of disadvantageous inequality. So if you like, you become it means that the indifference curves of more generous individuals, they become more rectangular looking. You know, they are steeper here and flatter here. So they are more approaching the rectangular, which is basically, for those who are used to work in this framework, which is close to a lexicographic Rawlsian preference. So they become more Rawlsian, if you like. More generous individuals generally become more Rawlsian in the sense that they become more selfish when they are worse off than the other individual, simultaneously becoming more generous when they are better off. Now, for the inequality averse individuals, it means more generosity goes together with more envy in the other domain. So this is one has to be very careful in interpreting what this positive correlation means for the different types. Okay.
Thank you.
Thank you for the question. Now, okay, so why does type switching occur? Well, if you look at this graph, for example, the 2020, the 2017 only sample, so you have individuals that are mainly in these clusters, but there are also some individuals who are not in the clusters. For example, individuals here in between. They are in between inequality aversion and altruism here. And it may be the case that some of these individuals move a little bit in this direction or in this direction, and that's why the types change. So that could be one reason why there is movement between the two other regarding types. Now, there is also a movement between the selfish or between these types, and you see there are dots here in between. They are not very numerous, but they are. So we haven't checked that, but we should. So we should really look at, so to speak, is it these individuals who are in between who really change the types? That would be a reasonable explanation, but I must confess we haven't done this yet. Now, let's look at the behavioral stability between 2017 and 2020. So when we look literally at the choices the individuals make in the different samples, and we do this by looking at their sets, we basically notice the set interpretation is the same as I have told you. If, for example, the individual is twice fully selfish here on a certain budget line, then this would be 0. There would be exactly the same choice. If the individual is twice egalitarian, it would be 3 minus 3. It would be the same choice. And when we look at this distribution of choices between 2017 and 2020, you see that in 55% of the cases, they literally make exactly the same choice. And when you look at the choices that are plus minus 2 units around what they did before, then that gives you 75% of the sample base of all choices. So there is, I think, remarkable stability, but not perfect stability, you know. So some move 3 units away and some move in the one direction or the other direction. So there is some movement, but overall, even at the individual choice level, it's quite remarkable that there's quite a lot of stability when they are 3 years apart. Okay, so next question then is, can we predict behavior out of sample with structural preference models? You know, now we go structural. So far, we have been totally non-structural. We just worked with non-parametric methods, but now we go structural, and we do this by estimating a utility function that is written down here. It's basically a Fehr-Schmidt utility function for the 2-person case. So individual I cares for the own payoff pi I minus the payoff difference when the other guy has a higher payoff and pi j is higher than pi I. Okay, so alpha measures aversion to disadvantageous inequality, and beta measures aversion to advantageous inequality when I am ahead of the other guy. And notice, allowing for distinct slopes alpha and beta is basically suggested by the data. It's suggested by the data. It's not. It would be wrong to impose the same slope here. This becomes most clear when you look at altruists versus inequality versus individuals. Okay, so now what we do is we have other tasks. We have other tasks, choice tasks, that are not in the center bundle. Notice that I showed you the 12 different budget lines. They were always in the center. They crossed the 45-degree line. But now we have non-center budget lines that are totally above the 45-degree line and totally below the 45-degree line, like on the left and on the right. And we now predict, we estimate the alpha and the beta at the type level, you know, for example, and also at the individual level to compare between type and individual level estimation. And we estimate the alphas and the betas based on the 12 subjects line that cross the 45-degree line. And then we use the estimated alpha and beta to predict the individual's choices for the budget lines that are not in the center. Okay. And we take the hit rate as our metric. So are the individuals exactly, so we have an exact prediction here. So they predict z equals 4, for example. And the question is, do they really choose z equals 4 for a particular budget line? Okay, that's the hit rate. Now, to give you an idea of what we do here, if we have a representative agent model, that's a model with two parameters. We have a representative type, so we estimate one alpha and one beta, which is an average alpha and an average beta for all individuals together. Okay. When we have a type-based model with 3 types, we estimate 6 parameters. We have for each type 2 parameters. That means we describe really the whole data set with only 6 parameters. When we estimate individual preferences, so for an alpha and a beta for each individual, we estimate between 700 and 1800 parameters. So we have many more estimates here. And the question is, are we, despite the fact that we remain very parsimonious, just with 6 parameters, are we still, how much do we lose in predictive power when we only work with 6 estimated parameters compared to 700 or 1800? Well, here you see what we find. So here we have the different samples in the different lines. The calibration data where we estimate preferences is always the center bundle. The predicted data is always what the individuals do in the displaced bundles. And here we compare the type-based prediction with the representative agent prediction. And the type-based prediction is always considerably better than the representative agent. For example, for the panel 2017 data, we predict correctly in 72.5% of the cases versus 65%, or it's even more dramatic here for the panel 2020. We are correct in 67% of the cases versus only 49% of the cases. So summarizing this, the type-based model is always considerably better than the representative agent model. Okay, and the random choice model, if people would choose entirely randomly, we would have a hit rate of 14%. You know, so even the representative agent model predicts much better than a random choice model. Okay, now let's look at let's compare the individual predictions when you estimate for any utility parameters for each individual with the type-based predictions. And here we find a really surprising and nice result. Notice that, for example, for the panel 2017, we predict better with the type-based prediction. For the panel, for the only 2017, this is the third line, we again predict better. And we predict nearly as good for the others. So basically, having a 6 parameter a description of the overall data with just 6 estimated parameters gives you this at least as good a prediction for out-of-sample behavior as a model where you estimate each individual's utility function. That I find quite remarkable. So parsimony, you don't lose anything in terms of predictive power when you go down the parsimonious route. Okay.
Ernst, if I may ask a question, do you have an intuition for that? Is it because the type identification helps you remove the noise at the individual level, or what is your intuition?
Well, I believe that when you do individual level estimates, you fit a lot of noise. So that is one thing. You fit a lot of noise. I have no better explanation than that. But it's quite remarkable. Actually, we have another paper. It's the Bruhin et al. Paper. It's the paper with Adrian Bruhin, Daniel Schunk, and myself, where we showed a very similar result. There we have also 3 types. And the 3-type model is almost as good, not quite, but almost as good as a model where you take all individuals' utility function for prediction. So I mean, we need more research to really show whether this is generally true, but I find it quite remarkable that a type-based approach can that you lose very little in terms of predictive power.
Thank you.
Now, the final point I want to make is, what about machine learning? Comparing machine learning models that are great predictive machines, with a structural model of preferences that you have recovered on the basis of a type classification. Okay, and we do here the within sample predictions and the out of sample predictions. So this is important to distinguish between within sample predictions. For example, when we take the within sample predictions and we look at the comparison between our type-based model, the hit rate of our type-based model, and the hit rate of the gradient boosting algorithm, which is a very good machine learning algorithm, then you see, so here we use the center data to predict center behavior, okay? And clearly machine learning does better. You need 99 point something percent, in 99 point something percent of the cases, they predict, the gradient boosting algorithm predicts correctly. But this is within sample. This is what machine learning is designed to do, be good at within sample predictions. But what happens when you predict based on a model where so basically you train the machine based on the center. So let me first explain what it means to predict within sample. Well, you train the machine based on the center data, and you predict then also the center data. And for the model is you estimate the model based on the center data, and then you predict based on the preference estimates for the center data. You predict the center data behavior. And you are much worse with the structural model, naturally, compared to machine learning approach. However, and that is the nice thing, if you predict the displaced, that means the out of sample behavior, then the machine does really badly. It only predicts in roughly 1/3 of the cases correctly, or even less than 1/3. Whereas the structural model that we have has a predictive power of between 67 and 72%. So, and that's what we want. We want, a good model is a model that you can apply to new data. And here, the structural approach, which provides you conceptual insight about what people really do. The machine is a black box, but the structural model gives you conceptual insights, how people behave and why, basically. And that knowledge seems to be very helpful for out-of-sample predictions. Okay, and with that, I come to my conclusions. So my first conclusion is that a non-parametric and very parsimonious characterization of the distribution of social preferences in broad population samples is possible. We don't have to make ex-ante assumptions on the existence of different types. We have no assumptions on the structure of utility functions. We have no assumptions on the structure of utility noise. And we non-parametrically identify clusters that strongly suggest qualitative properties of the preference types. Second, the same three fundamentally different types robustly emerge across all four data sets. A large share of inequality-averse subjects, a substantial share of altruistic subjects, and a non-negligible share of selfish subjects. Third, the types are characterized by particular combinations of alpha and beta that are not captured by the SVO measure currently used. In particular, inequality aversion means a positive alpha and a positive beta. Altruism means a negative alpha and a positive beta. And predominantly selfish individuals, predominant selfishness means alpha and beta close to 0. We also find a strong positive correlation between alpha and beta. That means higher altruism in the advantageous domain is associated with higher selfishness in the disadvantageous domain. And higher aheadness aversion in the advantageous domain is associated with more envy in the disadvantageous domain. Fifth, individuals' assignment to three types is relatively stable over time. We have 68% that have the same type 3 years apart. We have 70% switchers between altruism and inequality aversion, and we have 15% switchers between selfishness and other regarding types. And finally, the three-type model has remarkably good out-of-sample predictability. It's much better than the representative agent and a random choice model. It's equally good or even slightly better than an individual preference model, and it's much better than a machine learning algorithm. So thanks for your attention.
Thank you very much, Ernst, for an excellent and very illuminating talk. Let us open the floor for questions. I see one question by Pete Loon. Go ahead.
Hi, can you hear me?
Yes.
Okay, this is really nice. I just have a kind of insecurity in my head, though, that the simplicity with which your model is managing to explain here is linked to the simplicity of the task that you've used to derive the preferences. So if I have a choice between two very certain amounts to me and one other person, you've made very salient for me my selfishness, my altruism, or the inequality. And I wonder, I mean, I presume you have plans for this, but I mean, in many ways, it would be much more impressive if such a parsimonious attempt at measuring people's social preferences predicted behavior that's a social preferences task that's different from the task that you use to derive the preferences, that isn't just two certain allocations to two people.
Yeah, good, very good question. So what we did in one of our papers, I didn't talk about this, but you can download this paper. It's again with the same two co-authors, Thomas Epper and Julia Sen. We tried to predict preferences for political redistribution. Mm-hmm. So we measure people's distributional preferences, and then in Switzerland, we have a lot of direct democratic referenda. And we had in the last 10 years or so, many redistributive referenda that were initiated by left-wing student groups or left-wing youth groups that wanted to heavily redistribute income from the rich to the poor or help the poor, for example, minimum wage laws. And it turns out that the other regarding preferences in the form of inequality aversion and altruism are quite influential in explaining this preference for redistribution, which is from a completely different domain. You know, it's really an application to whether people support minimum wage laws or whether one initiative has been called the Fair Taxes Initiative, which aimed at redistributing income from the rich Swiss individuals to the poor Swiss individuals. And it turns out that that these preferences are quite important predictors of such political behavior, for example. I give you another example. We have Danish data. We are just about to write up that paper where we predict charitable donations in Denmark, and the data we use basically the data that you have seen. You know, we have even more. We have 9,000 individuals there, and we have the distributional preferences of 9,000 individuals. And from a theoretical viewpoint, one would predict that people who have an envious preference component, that is the alpha, positive alpha, that they are less willing to give to a charity, whereas people who are generous, have a positive beta, they're more willing to give to charities, and that's exactly what we find. So and actually these are administrative data, so these are not self-reported charitable donations data. These are objective data from the Danish Statistics Denmark. So this increases probably your trust into the predictive power of this type of distributional preferences.
Okay, thank you.
So we have a question by our former president, Gerrit Antonides. Gerrit, I think you can unmute yourself.
Yes, thank you. Very interesting talk and very powerful. I wonder if your three types would also be able to explain choices in a negative monetary area and choices with different cake sizes. What do you think?
Well, actually the different cake sizes, they are implicit already in, I mean, the stake sizes are is it different stake sizes or different cake sizes? And well, different cake sizes are almost inherently embedded into our measurement of distributional preferences, because in some of the budget lines, I could sacrifice $1 or a Swiss franc to increase the other individual's income by $4. And in other budget lines, I could increase the other individual's payoff only by half a Swiss franc. So which is automatically changing the cake size, so to speak. With my choice, I changed the cake size, and that in that way we measure basically a motive for. So, you know, one reason why I could be altruistic even in the domain of disadvantageous payoff is that I care for the total surplus of the two of us. And in that case, when I can give you 4, when I give up 1, that would be an attractive choice for me. So I believe the different cake sizes don't generate a problem. But you had another dimension that I forgot.
Yeah, the negative monetary outcomes.
We didn't do that. It would be interesting to. It would really be interesting to see what happens then when you allocate losses. Yeah.
Do you expect more types then?
More types? I have no good intuition, to be honest, what I should expect here.
Okay. Thank you.
But what I may add is, by the way, in one of the early versions of our political economy paper that I described before, you know, when we measured their preference for redistribution, we undertook the following task. So we asked, if we strip down, if we go from 12 budget lines as a basis for measurement of distributional preferences, if we go to 10, to 9, to 8, how far down can we go with our budget lines to still recover reasonably accurate types? And it turns out if you go down to 4 or 5, you are still relatively good, which is important to know, because you could incorporate incorporating 5 choices into an overall data collection exercise is much easier than incorporating 12 choices. So we have even identified which choices predict best, which budget lines predict the types best. So
we have a question by Valerio Capraro, who has been waiting for a while. Go on, Valerio.
Can you hear me?
yes.
Sure.
First of all, thanks a lot for this very interesting research. It was very fascinating to hear about it. So my feeling is that all the preferences that you can identify with your method depend on the economic consequences of the available actions. So borrowing a terminology from moral philosophy, these are consequentialist preferences.
Yes, yes.
I was wondering whether there is a way to measure also the ontological preferences with this method or a variant of this method, and whether you think that this may, for example, take into account or account for the remaining 30% of the observations that your method cannot account for.
So what exactly would be the difference between distributional consequentialist preferences and ontological preferences? So if I have a principle, so to speak, that I don't want to violate, that would be ontological. Or
yes, exactly. I think the difference is that there is evidence that some people make decisions without looking at the consequences that these decisions bring about. So, for example, two different frames of the same game may lead to different distributions of decisions. So in this case, distributional preferences would make the same predictions because the economic context of the two games are identical, but some people change decisions. So there is a small proportion of people. Yeah.
Well, there is a new theory by Angela Alger and Jürgen Weibull, that is a Kantian theory. It's a Kantian theory that where you ask yourself, what would I do if I were, what would I like the people to do if I were in the other people's shoes? So, and they apply this principle, so to speak. But I wonder whether this is ontological. I don't know. So to be honest, I don't know. I mean, there are non-consequentialist preferences, for example, preferences for reciprocity, where you respond to the kindness of other people's acts or to the perceived kindness of other people's acts, and not just to the consequences. I mean, there is a broad discussion in the literature about this type of non-consequentialist preferences, or also guilt-averse preferences, where you shy away from violating other people's expectations. These are non-consequentialist preferences, but not in the sense of ontological preferences. So there is a debate about consequentialism versus non-consequentialist social preferences in economics and psychology, but I don't know to what extent that overlaps with the notion of ontological preferences, to be honest. Yeah, so unfortunately, I cannot help much more, I think.
Okay, thanks a lot for the clarification anyway.
Okay, for the last question before we close, I give the word very fittingly to our current president, Vera Rita. Vera, you can just unmute yourself, I believe.
Many thanks, Carlos. Hello from Brazil, Professor Fehr. And thank you very much for the great talk and for inaugurating IAREP seminars. This is very interesting because parsimony is always so relevant for research. At the same time, it got me wondering about a couple of things that do you have any hypothesis for the consistency you found, the stability? Because we have data showing that people are rarely this consistent on one hand. And also whether you have data on gender and age differences. I noticed that in the Danish data, you have you controlled for age. I'm not sure about the original data though. Yeah. Thank you very much.
So with regard for the age question, I can tell you something. So we find, first of all, I must say that when we did when we started this research in 2017, I was really surprised that we found so many inequality-averse individuals. And I was surprised because the literature up to that point consisted mostly of student samples. And in student samples, we find very little inequality aversion. We are just writing up a paper on this. It's basically, it's like there's a missing type here. Students seem to be different. Now, the question is it students or is it age? And the data we have points towards age. The older people get, the higher are their alphas and betas. So there's a strong age gradient here. Older people are more inequality averse, basically, or more other regarding. So, and that's one important finding. And the other one is really don't rely on student samples here. I mean, I have taught for 20 years that student samples are not very different from other samples, at least at the qualitative level. And in the domain which is closest to my research, I was disproven basically. The students are just not very inequality averse. Whereas in broad population samples, I'm just writing up a review paper for the Journal of Economic Literature, and there I compile a whole list of nationally representative studies. And we see it in the US, we see it in Denmark, we see it in Switzerland, in Germany also. So there's a huge share of inequality averse individuals in the broad population. Whereas in the student samples, it's almost absent. Now, this is one thing. The other thing is stability and consistency across tasks and so on. I believe, I mean, there is a lot of research that seemingly shows that lab social preference measures are bad predictors of field behavior. And I could give a whole other talk how bad that literature is partly. I'm sorry to say that, and the problem is that the literature is often not very precise in what you can even expect, for example, or even the very notion of a social preference is sometimes mistaken in the literature. I give you an example. There are papers in management science that come up with the claim that first mover behavior in the trust game and in the ultimatum game does not predict some field behavior that they think it should predict. Now, the problem is the following. First mover behavior in the ultimatum game is totally confounded by individuals' expectations of what the other person does in the ultimatum game. So first mover behavior in the ultimatum game is just a ridiculous measure of social preferences. The same holds for first mover behavior in the trust game. It's totally confounded by people's beliefs about what the second mover does. Another example is behavior in the public goods game. In a simultaneously played public goods game, we know people are conditionally cooperators. Many people are conditional cooperators in public goods games. Being a conditional cooperator means I cooperate if I believe you cooperate. So my behavior depends on my beliefs and so if I believe you don't cooperate, I don't cooperate. That means even though I do have social preferences, namely conditionally cooperative social preferences, even though I have social preferences, you don't see it in the data because of my beliefs. So you can't use behavior in the public goods games as a measure of social preference. It's just not a good measure of social preferences. And a lot of the literature makes these mistakes. Even highly published papers in journals, in top econ journals, but also in top psych journals make this mistake, that they use confounded measures of social preferences. And you have to be very clear how you measure social preferences. And only then you learn something about whether they predict well or whether they don't predict well. So I would have to look in detail on your data to make up my mind of whether there's a real inconsistency or whether there is only an apparent or a seeming inconsistency in people's behavior. So that's a long answer to a short question, sorry. So.
No, many thanks. That was very enlightening. Thank you.
Thank you for an excellent talk, Ernst, and thank you to the audience for being here in our first seminar. And just to remind you, our talk in February is by Cass Sunstein, and please remember that also in February is the deadline to our yearly conference, so you're still in time. Thank you, everybody, and it's time to close the seminar.
Okay, thanks a lot for listening, and thanks a lot for the invitation. Bye-bye.
Bye.